Alright, so I just finished the part 4 section of the 4-part section of what ipv4 addressing means and like how all that stuff works, things like binary. It went really well. I was actually surprised by some of it, and how what we had to do to get around the fact that we needed to sorry, I'm thinking of the word, can't think of it right now. When we ran out of IP addresses, what we had to do. Because the way that IPv4 was originally set up was there was 4 different parts, like they had different class sets essentially. So they had A, B, C, and D. A and B were the most sought after because they were the the smaller numbers essentially. Because the way that works. So when you get an IP address, let me show my screen. When you get an IP address like 191 or 192.168.1.1, those octets will equal a certain amount of numbers overall. There's just over 4 million, I believe, is what it was for IPv4. So it four different brackets essentially with periods in there. With those 4 brackets, there was 8 binary bits essentially, 4 sets of 8 sets of binary. So you can actually go through and convert it all the way down to the computer code, which is kind of cool. Where you have, let's see, I'm pretty sure this is going to be on the test, but there's divisions essentially of what you can divide it by. So 192, for instance, is right here. So 192, you can divide it into, so you do 128 plus 64, and then you'll get 192. And then when you looked at, I didn't have it in these notes, but like the class A and B, yeah, here's these ones, A, B, C, and D. What they eventually did, so when they first set up the internet, they were just like, oh yeah, 4 million addresses, that's gonna be plenty fine for everybody. But then everybody started getting iPhone became a thing, and then cell phones became a thing. So you needed an iPhone, an IP address for yourself. You had possibly a tablet, a laptop, a desktop computer. When IPv4 first came out, basically everything was able to just reach out to the internet and communicate with people. Obviously that became a really big problem really quickly. So what they ended up doing was really cool. Is they so they grabbed they made it so that there was a private IP address list, and then there was the public facing. So what they did is they basically dissolved most of class A and B into private IP addresses, meaning that they're like local IP addresses. That's why usually when you're connected to your router, it's usually 192.168.1.1 because that's a private IP address, and that's part of that class A and B. And then everything else that was available was allowed to be external. So what they did was it made it so that you didn't need as many IP addresses available for everybody else out in the outside of sorry, I was just trying to think of what the other part was. There was variable link subnet masking is what it was. I haven't gotten into the subnet masking yet, just because that's the way they didn't talk about it a ton, but they just briefly said it. Basically allows, yeah, that's what I thought. Okay, address space into a hierarchy of subnets of different sizes. So basically creating buckets. So that's what they had to do, is they had to create buckets and compartmentalize stuff so that they would get less conflicts. But you could have millions of IP addresses on one network and then still be okay, because you only needed for a giant business, you only need maybe 2, maybe 3 IP addresses in total. So that reduced the cost down a lot. Eventually they did come up with a replacement for that's what IPv6 is. I haven't gone through that yet in my training. Let's see. the way that it was explained, yeah. So IPv6 is binary to hexadecimal instead of the way IPv4 is, which is binary to dotted decimal notation. Hexadecimal is basically so with IPv4, which is the numbers. Well, with hexadecimal, you're adding letters into the mix as well, so the numbers can become massively giant with no end to them. Essentially, like they were comparing it to like, hey, you could literally give everybody 1 million IP addresses, and you'd still not run out. So they're like, it's impossible almost. We'd have to have such an intent, like you'd almost have to look into like a multi-planetary situation. But then even again, they would just do subnet masks. Like they would just do like, oh yeah, this is the IP addresses for Mars, for instance. So that still wouldn't be a problem because there's obviously going to have to be a funnel going for multi-planetary stuff. So yeah, that's a whole other topic, I guess. If that ever does happen, I just think of like all those sci-fi movies where they're like multi-planetary. I'm like, I wonder how the internet's gonna work. Oh, it's not. They're probably gonna have a huge delay, and they're probably just gonna have their own version of YouTube and stuff. Just kind of like China kind of secludes themselves in a lot of cases for all their media and stuff, which is fine. It's just different the way they do things. But yeah, I think it was pretty brilliant the way they handled IPv4. It makes sense why they had to make those changes that they did. And from a binary perspective, it's very basic. I remember growing up playing Diablo 2, and we'd have problems with IP conflicts on our local network, and we'd have to actually create static IP addresses. So normally with your computer, let me explain what a static IP address is first. So normally with a computer, when you set those up, you will set up your computer automatically set to auto grab an IP address from the router and say, hey, this is my new IP address. And it sometimes will recycle those every once in a while. But sometimes we would run into conflicts where it wouldn't recycle properly, or it would change on us. So we would a lot of times, since with like Diablo 2, you could have local hosting happening on a device, so that you could everybody could connect to that computer essentially. So we would create a static IP address, and what that does is instead of it grabbing just a random one, it would grab it would keep a consistent and consistent one, kind of like how the router is always going to be the 192.168 unless you go into their settings and change it. But I digress. So you create a IP address for that computer, and then we would be able to all just remote into it and make it a lot easier to just keep track of that stuff, so we wouldn't have conflicts happening. Obviously, with video games nowadays, most of them are all online, and you don't have to run into that stuff. But back when you didn't really have the fastest internet, or you just wanted to play with your buddies locally, I mean, Diablo 2 was great for that. So was like Unreal Tournament and Quake and stuff. It was fantastic because you didn't have to worry about internet lag happening. I used to. It was like back when before I was 16, before I even had a car. So I was dragging CRT monitors and a wagon. I put a CRT monitor on my desktop computer in a wagon and just wheeled it over to my friend's house because we didn't have a car. That was totally normal back then. Just a giant CRT monitor. I always wonder what the neighbors were thinking. Like, hey, you probably shouldn't be carrying your computer around like that. But it was totally fine. It was great. It was a lot of fun. Those monitors were not fun. We had one of the flat panel CRT monitors, which are like, I swear they're twice as heavy as the regular CRTs. But yeah, that thing was not fun to move around. But it was educational. We learned a lot. Because especially since there wasn't, Wi-Fi wasn't really a big thing back then either. So you had to manually plug stuff in. You had to figure out, how to plug in your mouse because, PS2 connectors, you had to always plug it in the right thing. And that's how I grew up. It was very helpful for me to grow into this because I already knew everything. Some people are like, how do you know all this? I'm like, I've been literally doing this stuff since I was 5, with DOS prompt. So ipv4 addressing, I knew about it and I kind of understood it and I knew the core concepts, but now that I understand that, you know, there's a binary form of it, why we're specifically using certain IP ranges on local networks, that helps a lot. Actually makes it a lot easier to just create local IP addresses than having to do it all in hexadecimal, which is going to give a whole lot more headaches, you know, just because it's not needed on the local. So I'm glad they kept it simple for the local networks. Makes my life easier to memorize all this. But yeah, I'm excited to see what. So the next chapter I have is subnet masks. That's why I was looking at variable link subnet masking and how that works. So that's my next section I'm jumping into. I'm excited. This is gonna be. Come on, no notifications. Let's see. Yeah, so subnet masking reminds me of the conflict that happened a couple weeks ago where a small internet, yeah, this is an interesting article. I might have to go over this sometime. Basically what they ended up doing is the routing got screwed up because they were using the wrong IP addresses essentially, and accidentally grabbed like a massive chunk of the internet and pulled it to this small internet provider and basically just dumped all the internet on there. I think it wasn't Verizon. Verizon wasn't the one to, even though Verizon was the main. So with subnet masking, like I said, it's a hierarchical situation. So Verizon was on top, and then there was an ISP basically routing their traffic through Verizon. Well, Verizon thought it'd be brilliant. Here's a great chart. Verizon thought it was brilliant to not to have any stopgaps in place to prevent, you know, somebody just accidentally grabbing an entire IP range through their network. So Cloudflare is a massive company. They have they own it. A lot of people host their websites through them. So then with Cloudflare, they went through this transient network and then got routed through these guys. I didn't read through this a ton. I just remember part of the article. And then essentially, Verizon was probably the biggest player. Like, yeah, it was the ISP's fault, but Cloudflare was spent like 7 or 8 hours, I think is what they said, trying to get a hold of Verizon to just like fix the problem, because Cloudflare is like also our systems are like completely down. 15% of global traffic, 15% of the internet just got routed through past Verizon without them realizing it. That's just laziness so much. I'm gonna have to read through this now. Anyways, yeah, IPv4 addressing. I'm going on a tangent again, but yeah, I'm excited and see where IPv6 and subnet masking is, because I know that's the next step on where we're going to be going. So I'm going to upload this now, and then I'm probably going to upload another little update video later on. So see you guys later, and it's a pleasure talking with you.